So hi everyone who's here, hi everybody who's live streaming. We're going to get started in a second. How has everyone gone in week 1 though? Good, I hope so. Has anyone joined CSESOC? Has anyone heard of it? Yeah? There's a computer science and engineering sort of society you can join. I think they've got barbecues each week. I don't know. But find out about CSESOC if you're interested in that kind of thing. All right, let's get started. Shh, 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 shh. There's a little bit of noise. Do you mind just shutting the door? Thanks, cool. All right, so hopefully everyone's been to their tutorial and lab last week and you've got to know your tutors. Hopefully you all did well with your first lab. The first lab was not worth any marks, okay? That was just to get you started in the course, okay? Yeah, and so last week in the lectures we did just the basics of expressions and variables, printing stuff out. We did not finish all the content. There was one little bit that I didn't get up to, so we will do that today. Oh yeah, just a reminder that this week the labs are worth marks. So the exercises that you do in the lab, you'll need to submit them by Monday 8 p.m. the following week, okay? Not tonight, Monday in week 3 for a week 2 lab, okay? Has anyone had a look at the week 2 lab yet? All right, don't worry, it came out last night at 8 p.m. But there are 1-dot questions, like they're labelled 1 dot. And they're the real core content that we hope everyone can do every week. Then there's the 2-dot questions. They're a little bit more challenging, but we still hope everyone can do them at least most weeks. Then there are the 3-dot questions. Now the 3-dot questions are often very challenging, very time consuming. Most people won't be able to do all the 3-dot questions each week. You might never do any 3-dot questions. That's okay. You can still pass the course and do really well, but they're there for a challenge. So give them a go, try them out. But don't then think, oh no, I can't do these, I'm going to fail. They're meant to be challenging. They're meant to be for people that, you know, want a challenge, which I hope is all of you, but the challenge is in doing them, not necessarily getting them all out perfectly. They're only worth challenge marks, bonus marks as well. So you don't have to do them to get full marks in the lab component. All right, and your tutor will go through all of these details as well this week, but just in case people are wondering. Okay, hands up if you want to do a bit of a recap before we start doing new stuff. Okay, all right, we'll do a bit of a recap first. Then we'll talk about the thing I didn't finish from last week's lectures. Then we're going to do something called if statements. We may or may not get up to while loops today. We might not, but we'll see how we go. Okay, so the lecture code is available here. So every week you can access the live lecture code, usually a day or so before the lecture. Some of it's there during the lecture. Do I have my phone on silent? Yes. Okay. During the lecture and then after the lecture. Okay, so for people who like to sort of look at what we're doing in the code, it's there. All right. So we're going to start with a brief recap, and I will go into VS Code because then we can run stuff. Okay. I hope everyone's going well with the terminal and VS Code and getting used to it. All right, here's a heap of code. What's it doing? All right, let's just step through some of it. I'll just step, and if there's any questions you have or that anything you're not sure about, just ask. So here, we're declaring a variable called number of weeks, okay? And when we do that, we're asking for a chunk of memory big enough to store one int, and then we're putting the value 10 inside it, right? That's what this line of code is doing. Is everybody happy with that? And then in our code, we can call it number of weeks. We're doing it again. This time we're asking for a different type, a double type, whereas we wouldn't be able to store 95.5 in an int variable. It can only store whole numbers. All right, is everyone happy with double versus int? Any questions? All right, then we've got a char variable. Now, we typically store characters in char variables, and we're storing a capital B in this instance. Hi, everyone. Hello. So we're storing a capital B. That's how we want to think about it. How is the system actually storing it? As an integer. We don't have to have memorized exactly what that integer is. It's going to store it as an integer, but we're really just going to think about it as a capital B for most of the time. Cool. All right. So once we've got these variables, we typically want to do something with them. In this example, it's quite simple. We're just, for the most part, printing them out. So to print out variables, again, we just use printf. But if I want to print out an integer, I have to put this %d there. %d means I want to print an integer in this place in the string that I'm printing out. What integer? I need to tell C what integer I want it to print, and I have to put that over here. I've got to put the list of variables I want it to print. In this case, I'm saying, please print there are some number of weeks. Now it gets that some number of weeks from this variable, which happens to be called number of weeks. Anyway, it's going to go to that variable, get the value 10 out, and print there are 10 weeks. Is everyone happy with the way printf %d? Okay, cool. All right. This is a similar thing here, but %lf means we're printing a double. So you will remember these codes as once you practice them a bit. Down here we've got %c. We're printing out a character as a character. So that will print out, you got a B. All right, and I'll run it in a second so we can see. Now down here we've got a little bit of an expression, a simple expression. So we've got our variable distance in centimetres. It's currently equal to 95.5. And we're just saying, let's take the value that's inside that variable. So distance in centimetres right now is equal to 95.5. And we're subtracting 5 from that. And we're going to get 90.5. Okay. Then we're storing this value, back into our variable. Okay. So up here in this variable, we've actually modified it. We've modified it. It's now going to store this 90.5 back in there. Okay, so is everyone happy with this? We've taken the variable value, which was 95.5. We've subtracted 5. We get 90.5 and we store it back in the variable. Now we've changed it. And now when we print it out, this is going to say 90.5. So I'll just run it. So I'm going to compile it. Now I'm going to run it. And it says there are 10 weeks. The distance is 95.5 centimetres. You got a B. And then now, after I changed that variable, I print it out and I've got the updated value. Okay, did you have a question?
Yeah, so what's it mean to have it stored back into the variable?
Well, now the variable has changed.
Does it, hold on. If we have it on a loop, what will happen?
Well, we'll talk about loops later, but so that variable could store a number. The number it was storing was 95.5. That's gone now. We've overwritten that, and now it's 90.5.
But if you run the code again, it goes back to 95.5.
Yeah, if I run it again, because now that memory is stored in RAM. Once the program finishes, all that memory is gone, like wiped clean, and it starts again. So when we run it again, it's going to step through this process and create this variable again. If I run my code again, it'll start from here and it'll set it back to 95.5. Yeah. So it doesn't keep that variable within, like, the next time we run the program. The next time we run the program, everything's reset, yeah, and starts from new. There's a hand up over there. Yeah?
Yeah, so in the second line, did you just redefine what the distance in centimeters is? Like distance in centimeters equals to the distance in centimeters? Because,
Here?
yeah.
So basically this is like saying, I'll do a sort of simple one. I might have something like int x equals 5, right? And then I might say x equals x plus 1. So
My logic, wouldn't that like cause the like computer get confused to either show 95.5 or like some other number?
okay, so I think in maths, sometimes you might do equations where you're balancing them and you're saying x equals x plus 1 and you're trying to work out what x could equal, right? And then this isn't the way it works. We're saying this is like an action. We're saying work out what this is, right? So it's not like maths where you're trying to balance an equation and find out what x is or something. We're saying let's evaluate this on the right-hand side. So right now, distance in centimeters, which is stored in a variable, is equal to 95.5, right? That's what the current value is. If I take 95.5 and subtract 5, I'm going to get 90.5, yeah? So the right-hand side of this, that expression evaluates to 90.5. Now, in C, when we use this equals thing, it's called an assignment, and we're assigning this value to this variable. So this is like saying distance in centimeters is now equal to 90.5.
Oh, so they aren't the same thing.
So now this variable that we had has been modified. It now has the value 90.5.
Oh, but so they aren't the same thing.
Well, the right-hand side is you're asking for the current value of that variable. You're then doing some kind of computation, and you're storing the result back over the original value. Yeah, and this is a really common thing to do. And after doing years of maths, it does seem a bit weird that we're not just trying to balance an equation and when we're not saying these two things are equal. We're saying, let's do this, put this into this variable. Yeah. Okay, thank you for asking that, because lots of people get confused about that. So that's a really good question. Okay, so that's, yeah, one more question. Yeah.
So when we run the program again, then it's still going to read it as 95.5 instead of 90.5.
Yeah, next time we run it, the program is going to always start at the first line in main. So when we rerun our program, any variables or data that we had before is just completely gone. And we start afresh, we run it from top to bottom again, like, you know, nothing ever happened before. Yeah. All right. Okay. So let's move on. This one over here, I've declared two variables x and y. So when I do this like this, what is in x and y right now if we're up to this line here? Well, when I do it like this, I haven't given them any values. Right now, we say they're uninitialized. There's no actual valid data in there. Maybe there's some garbage, junk, random data in there. We don't know. But we don't have data in there that we've set that we can use. Now, we've done it like this in this particular program because we're going to read it in from the user. So we're going to do a scanf. So my next line, I'm saying scanf %d% because I want the user to type in two integers. And I'm telling scanf, we'll put the first integer that they type in into variable x, put the second integer they type in into variable y. So that's how they're going to be initialized with data from the user. So after that's happened, it's just then going to print it out, right? We're doing the same thing again down here, but just for an example, I've made it a double. So next time around, the user has to enter a double or a real number. We read that in and print that out. And again, we use LF for double. I'll just get rid of my scribble. So I think I've already compiled this one before. Actually, I'll do a clear. All right, so it's saying enter 2 integers, and I'm going to do the right thing and enter 2 integers. Now, it doesn't matter if I put lots of spaces here or anything like that when we're reading in integers. It will just ignore them. And that's going to give us 4 and 99. Yeah? Yep.
And is it possible to put the prompt print out to Scanf rather than 2 lines? Combine them to 1 line.
Oh, right. So you're saying if I typed it in, I think this is what you're saying. Would it be okay if I did it like this?
No, I mean in the code.
Oh,
I mean,
I could do 2 scanfs. Yeah. I could say enter 1 integer, enter another integer.
I mean the printf enter 2 integers. Is it possible to put this string in the Scanf like Python?
No, not like Python. Not like Python. So in Python, you can read something in and also print out your message at the same time. Here we have to do the printf, then the scanf. Yep, good question. Yeah. All right. So I've entered 2 integers. I'm now going to enter something else, whatever. It's going to read it in and print it out. All right. So that's printf scanf. Now, does anyone remember what happens with characters? Oh, yeah, so we've had a good answer. What happens with characters? If you put a space in front of the %C, it ignores any white space. So let's try this out. Recap scanf char, blah, blah. All right, so if I type in the letter A, for example, it's going to read it in and print it out. If I type in a space, I've only asked it to read in 1 character. It's going to read in that space, print out a space, because a space is a character. If I type in a new line, or like press enter, that's a new line, it reads in a new line, it prints it out. Sometimes I don't actually want that behavior. Sometimes I don't want to read in all the spaces, I just want to ignore them. And that's when I can use this special magic scanf version. I just put a space, 1 space here, and it actually ignores all white space. Hang on, I've got to recompile it because I've just changed it. Okay. So now, even if I do lots of spaces, lots of new lines, tabs, 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 it's just going to keep ignoring me until I do something that isn't white space. We call that white space. So I could type in like a question mark, just a character that's not a space or new line, and it reads that in and prints it out. Sometimes in the labs you'll find that that's a handy option, and often they'll just give you a hint that maybe you can use it. In things like assignments or exams, maybe you'll have to think, oh, I want to use it without the hint. All right. Do you have a question? Oh, it's all right if you do. Yep. Just by putting that 1 space tells Scanf, it's just a feature of Scanf, they decided this is how it's going to work. You put that 1 space there and it can ignore white space, any white space, any spaces, tabs, new lines. And it's just if that's what you want it to do. If you don't, if you want to read in those spaces, then you don't put that space there. Yeah. So it's not like logical, it's just the way they decided Scanf would work. because that looks like one space to me, right? I wouldn't have guessed that that's what it does. Okay, here's a tricky expression, I guess. What is this going to do? So when I run it, well, we can probably see it's trying to do the average of two numbers based on everything we're printing out and the variable names. So it's reading in two integers. So I can type in, say, 4 and 6. And what should the average be of 4 and 6? Yeah, 5. And it works. Good, we're done. No, we have to test other things. What do you suggest I test that might not work so well with this?
3 and 2.
Yeah, 3 and 2. What should the average be? 2.5. Well, what would we normally want the average to be? Yeah, we would usually want the average to be 2.5. But what are we going to get? We're going to get 2. Okay? So if we really want averages like 2.5 or something, how could we change this code? Yeah? Yep, we could turn things into doubles. Now we could just turn everything in this code into a double and that would work fine. What if we didn't want to do that? What if we wanted the user to only be able to enter integers, but we wanted to have the average as a double? Yeah. Yeah, if I wanted to, for whatever reason, keep the others as ints, or I was given ints from somewhere else, I could just change this. And as soon as I can't type, as soon as I've got one double, if I'm dividing, as soon as one side's a double, it turns the other side into a double and does double division. Then I get my 0.5.
So does it automatically convert x and y into doubles?
So we would do x plus, it doesn't convert x and y, but who asked, I don't know who, yeah. So when you do x plus y, that would give you an integer, right? They're both integers. Integer plus integer gives me integer. But then when we do integer divided by double, it just promotes that integer to a double to do that calculation. It doesn't actually go and change the type of x and y. It just changes the type of during the calculation, if that's what you mean. Yeah, but it does that automatically. Okay, so and then we've got to change this to %lf. Okay, that's good. People have remembered that because that can really be very confusing getting answers like that. Let's try it. I'm running the wrong question. I'm running the wrong thing. I'm not even running the right program. Let's compile the correct program. I was running the Scanf one. Okay. Enter two integers, 2 and 3, for example. Oh, phew. Okay. Now, this is just something that I don't think I've even told you about, that you'd have no way of knowing, like just from these lectures. What happens in maths when you divide by 0? Does anyone know?
No,
Yeah, it's undefined. Now, in computing, it's undefined too. Now, if I try and do this, it's actually warning me. I don't know if you can see that. Division by 0. It's warning me, don't do this. What if I ignore the warnings? I ignore all the warnings and go ahead. I get a runtime error. It says runtime error, division by 0. Now the thing is, our compiler could tell us then because it's very obvious, but sometimes it's not so obvious because maybe a user has entered the number you're dividing by, and the compiler can't read the user's mind. So this is getting a bit messy, but here I'm doing a scanf to get an x, and then I'm dividing by it. So the compiler hasn't warned me because it can't read the mind of the person who's about to type a number in. So if I type in something that isn't 0, you know, it works. If I type in something that is 0, it crashes, right? Runtime error. So we're going to learn things today when we get through this recap of how to do different things in different situations. We can test, well, if x is equal to 0, we better not do this. We can do stuff like that when we get through today's lecture. But for now, just to let you know, dividing by 0 is not good.
So that would be a case where we use if.
Yeah, that's a case where we could use if. If x is equal to 0, and we'll see what ifs are later. Don't worry if you don't even know what they are. Yeah, don't do that. Okay. All right, here are some tricky expressions using characters or chars. So we all know that we've got this ASCII table and that all of our chars are really stored as numbers. But what on earth is this expression doing?
It's giving the lowercase b.
Yeah, it is. It's giving a lowercase b. Now, why does that work? Well, basically, oh, that's not working. If we look at this ASCII table, and just doing -d gets rid of some of the extra rubbish showing us hexadecimal codes, yeah, we can see that these are in order. So if we do something like b minus a, capital B minus capital A, what we're really getting is 1, or the distance that B is into the alphabet. Like if we did capital C minus capital A, we'd get 2 because it's 2 in. So if I then take that and add it on to the beginning of the lowercase alphabet, it's going to go 1 into the lowercase alphabet and give me a lowercase b. So this is the way we can convert between uppercase and lowercase in C. So hopefully that makes sense. If it doesn't, you might have to look this formula up until it makes sense in your head, and this is how you can do it. Yep.
I assume then if you take A and minus it by B, you'll just get -1? Or
Yeah, you would get -1.
I see.
Yep.
That's it.
Yeah, definitely you would. Now, you can do this the other way around as well. So I could say, well, let's take lowercase b, subtract uppercase A, you're going to get 1. Add that onto an uppercase A, you're going to get uppercase B, right? Now, if you take something that's not an uppercase letter and do this, you're going to get weird rubbish, right? Okay. Which will be another thing that we look at with if statements later. Don't do this unless it is an uppercase letter to begin with or whatever. Okay, so yeah, you can try that and check it out. What would this last one do?
Uppercase c.
Yeah, uppercase E. Yep.
How do we decide to which should we add 1?
Oh, so when we do it like this, what we do is if I've got an uppercase B, I'm going to subtract the uppercase A always. Then I'm going to add a lowercase a, and that's going to convert from upper to lower. If I've got a lowercase letter, I'm going to subtract the lowercase a. Yep.
For example, if I want to subtract d minus b, and then I use a lowercase b after that to add.
Well, yeah, I think that would work too. But typically this is the way we do it. A is the first letter, so we typically use that as the reference point for the start of the uppercase alphabet or the start of the lowercase alphabet. But yeah, lots of different formulas will work out with this, but that's typically how we would do it. Sorry?
We just add 26, subtract 26 if we need a lowercase letter.
Well, they're not like that. So the uppercase letters and the lowercase letters, if we have a look here, how far apart is lowercase a and uppercase A? Yeah, it's 32. So yeah, some people remember the number 32 and add or subtract that. I find it easy to do it like this, but It just depends. Yeah, that'll work. Add or, and then I forget, am I adding or subtracting the 32? I get mixed up easily with that. But yeah, this is how I do it. All right. So the thing we didn't get, so this was the recap. So hopefully that kind of has helped remind you what we did. We've now got this thing we're going to look at called constants. So sometimes we've got numbers that we want to use in our program, and they're not going to change while our program's running. We're not going to say pi equals pi plus 1, or, you know, pi equals pi times 1,000. We're not going to change the value of pi while our program's running. And sometimes we might have like a maximum size of something that isn't going to change while it's running. It's just some number that we want to use, and we want to store them so we don't just have random numbers through our code and we don't know what they mean. We want to give them a name, but we don't want to be able to change them. We call these constants. The way we're doing it in this course, and there are other ways, but we're using hash define. So with our hash defines, we put them after our hash includes, but before our main function. So they're visible all throughout our file. We say hash define, we give it some name, and we give it some value. As you might see here, there's no equals, there's no semicolon. We just give the name and the value. For style reasons, we keep it in capitals, because then when we use them in our code, if we see that they are all capitals, we know straight away they're constants, and then we're not going to be tempted to accidentally say, oh, let's add 1 to it or something like that. So that's a style thing. Yeah.
Are these constants stored as doubles or integers?
Well, that's a good question. We haven't given it types. So look, this isn't maybe necessary to know, but it doesn't really store them anywhere. Before the program runs, before you compile the program, in the first step of compilation, it'll really go through and basically do it copy and paste. And everywhere you've written max size, it'll paste in the value 12. So it's not going to compile if you use these constants in the wrong context, right? Or, yeah. Yep.
What are the cases in which an integer type gets typecasted? Do they get typecast like an integer data type gets typecast to a double data type?
So the question was about typecasting integers to doubles. So that'll happen automatically when you're doing something like 2 divided by 2.0. That'll do the whole expression as doubles, okay?
Where is the case in which you did C plus 2 divided by 2.0? It didn't do it in that case.
That's going back. Do you want to come and ask me on? Okay. So over here, were you asking? Yeah, if we divide it by 2.0, it'll do the whole expression as double. It doesn't change these variables. It just changes these values here when we do that division. Okay. All right, let's get into some coding. We're just going to do this very simple example. I'm going to use a constant in there just to see how it works with a simple constant, and then we'll move on and do ifs. Okay, yep.
I don't understand. If we have, so divide is supposed to be a number that never changes, right?
Yeah.
Why not just never write a code where there is pi equals to pi plus 3? Why not just never write a code like that? Wouldn't that solve the problem?
So the question is, why don't we just make sure we never write the code that tries to change the constant? The whole thing is when we have a compiler, it's there, and types, it's there to help us and pick up things that we might be doing by accident, that we don't want to do. So it's just a safety check so we don't try and do things that we don't want to do.
Constants use less memory compared to variables, right?
In this context, yeah, a hash define won't take up any memory, and a variable does. But the main thing that we really want is to just, these are very small programs that we're looking at. when you get into a huge program that lots of different people have written, the more you can get your compiler to help you and say, no, why are you trying to add 1 to that? Like, you know, the easier it is to get, you know, to have consistent bug-free code. Yeah. So yeah, you could still get your program to work by sticking pi in a variable. That's true. Yeah. Good. That's a good question. All right. So let's just code up this example. It's just a simple example putting stuff together. What's the time? Okay, we've got time. So basically, we're going to convert, and this is an easy conversion, I hope. Please enter the number of hours. So we've got to make sure we prompt the user first, and I'm going to do that with a printf. I've copied and pasted it so I didn't make typos. Then I'm going to scan in some kind of variable, like some number of hours. What type do I need to make it to store this? Yeah, and I'm going to call it hours instead of just like X or something. And I'm going to use %lf because it's a double, and I'm going to scan it into hours. Is this correct? No. Yeah. Exactly. We need that ampersand. If we don't put it, the compiler will warn us. But yep, that's right. So we've got some good eagle eyes in the audience. Now I need to actually calculate the number of minutes. So maybe I'll create a variable for that called minutes. And I need some kind of expression. So how do I convert hours to minutes? Yeah, I just say minutes equals hours times 60. Then I can print out that is however many minutes and put the minutes in here. And that will work. Now, since the number 60 is representing the number of minutes in an hour, and since that's never going to change, we could put that up the top as a constant. We could say hash define minutes in hour 60, right? So if we've got a hash define like that up the top, instead of putting the 60 down here, we then put minutes in hour. This is how we actually use the constant in the code. Now this is a pretty simple situation, but we'll see lots more cases of doing something like this. Now let's just compile it. And I didn't save it. Oh. Okay, please enter the number of hours, 2.5. We get 150 minutes. You should check more thoroughly than this, but we don't have time. And maybe I would put it to match the required output. If this was a lab, I'd want to make sure I put the right number of decimal places in. Okay, all right. Yeah?
This 0.2 means the digit after the point, right?
Yeah, so 0.2 means 2 decimal places, like after that, yeah. It means it's going to print it out to 2 places after that point. Otherwise, by default, it's 6. So that's a common formatting thing we use in printf if we're using doubles. Okay, let's move on to some new stuff. So making decisions with if. And yeah, let's start going. So sometimes you want C to make decisions. Oh, yeah, question?
When you define a constant, is that an executable statement or is it just something that's like, because there's no semicolon?
Yeah, yeah, good observation. There's no semicolon. It's up the top. It's not an executable statement, and it just the compiler before it starts compiling everything just basically does a search and replace with all of those. For this course, don't worry if you don't. Those details aren't necessary for this course to know the underlying mechanisms of it all. But it's interesting to know. All right. So, if statements. Sometimes we want to do different things in different situations in our code. So far, our code is just starting at the first line in main and going line by line by line. Sometimes we want to do something in one situation and something in another. To be able to do that, we need to be able to ask questions to work out what situation we're in. So we want to make decisions based on true or false questions. So it might be like, is x even? Is y greater than 10? Is x less than y? These are the sorts of questions we might be asking to do different things in those situations. Yeah, is x equal to 0 before we divide by it? Things like that. Now, in C, true and false are represented by integers. So naught is false. So naught means the number naught, but it also means false in C. 1 or any other value that's not naught, that's an integer, represents true. So if I said to you true or false and you're in C, you'd be going 1 or 0 to say true or false. Okay, once we've got our true or false question, which we call a condition, we can use an if statement that says, if this condition is true, do the code inside these curly brackets. Okay? If that condition is not true, the code in here does not get executed. Now, in order to make these conditions, we need some ways of comparing things. So a lot of these operators might look familiar from doing maths, like less than, greater than. Sometimes the way we type them in looks a bit different. This is less than or equal, greater than or equal. This one here is equals equals. This allows you to compare two numbers. So people sometimes when they start get equals equals confused with equals, which is fair enough. So equals equals is comparing. It's saying, is this number equal to this number? 1 equals is saying, make this number equal this. Put this value into this variable. So equals is doing something. Equals is asking something. Yep. Yep, that's right. We can use equals equals to see if two letters are the same, two numbers are the same. Yep. And because letters, individual letters are actually stored as numbers, so it can easily do that. And we've got a not equals as well. So these are the kinds of operators we can use to work out our true and false questions and to put into conditions in our if statements. Now, we're not going to go into this in great detail, but just be aware that if you're dealing with doubles, if you've done lots of calculations and you've got some double value, using equals equals can be a bit tricky. So you might have something that mathematically should equal 0, for example. In the world of maths, your calculation would give you 0. In the world of doubles and computing, maybe your calculation gives you 0.00000000001. Now, if you do an equals equals, it's going to say, no, they're not equals. If you say, are they not equal? Yeah, they're not equal. So when we're dealing with doubles, sometimes we will check if it's within a range around what we consider is close enough to 0 or whatever it is we're looking at. Most of the time in this course, it's not going to matter, right? But it's just also just a tip. Don't go around using doubles for everything, because sometimes people think it's much easier if I use doubles for everything, because then I don't have to worry about not getting my fraction or whatever. But don't use it unless you need to, because integers are cleaner for these sorts of things, if your integer works for you. All right, so true or false. I'll let you say true or false. You don't have to say 1 or 0. 5 is less than 2. False. Yeah, everyone call it out. Be confident. X is greater than 2. Now remember, X is 4. True. That's right. Oh, we're up to here. X is less than or equal to 4. Yeah, it's true because 4 is equal to 4. Yep. 3 is greater than or equal to X. False. X is equal to minus 4. A is not equal to B. Correct. Capital A is most definitely not equal to capital B. All right. So these are the relational operators. Now I've put this into a program. Again, I'm going to bring it up in... Oh, okay. I'm going to bring it up in here because then we can run it. Oh, one thing I forgot to mention, and I knew I'd forget it, so I wrote a note to myself. Indentation. So notice the way, like when I've done this printf here, it's not sitting here. I've indented at one level. So the rule is every time you've got an open squiggly bracket, you've got a block of code, and everything goes in a level. So inside the main, things are aligned, one level in. But now I've got another open squiggly bracket because I've got an if block. So everything inside that is indented another level. But when we get the curly closed bracket, we come back out another level again. So basically, look, it should look like this. Yep.
When you've opened your file with code, what's the little asterisk stand for? An asterisk and the .c.
Okay. So again, this isn't something you necessarily need to memorize, but there are kind of wildcards when you're using Linux. Okay. So star.c means anything.c. So I just did that because I got a lot of files and I didn't want to type them in one by one. And I didn't want to open up any executables that don't end with C, because has anyone tried to open one of their executable files by accident? Actually, it takes a long time and it's annoying. Okay, now what on earth does if 1 mean? Yeah, 1 is true. 1 actually means true. So it's saying, is true true? Yes. So it's going to print this out. This one here, what's this saying? False. Is false true? No. So it's not going to print this out, right? Is it going to print this out? Yes. 4 equal to 4. Sorry, I'm highlighting two different things at once. Is 4 equal to 4? Yeah, it's going to print that out. Is capital Z equal to lowercase z? Yep, so it's not going to print this out. File, blah, 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 I don't even know what I'm saying anymore. Is x less than 0? No, it's not going to print this out. Is y greater than or equal to x? My brain is getting slower at thinking about this, right? I'm thinking 10, 5, yes. We're going to print that out. This is a horrible one, isn't it? Let me just bring this down so you can see it. Is x not equal to y? Yeah, x is not equal to y, so it should print that out. Okay, I'm just going to move this around a little bit. Hang on, yep. So let's have a look at these ones first, and I'll just run it. I better compile it. So yeah, prints hooray like we guessed, or not guessed, deduced, that might be the right word. It didn't print this like we'd worked out. Ugh. Yeah, it didn't print yay. It did print I love C. It didn't print I am cool. Down here, it didn't print X is negative. It did print Y is greater or equal. And it did print X and Y not equal. Okay, so you all answered it all correctly. Yep.
I don't get the if one and if. There's no condition, so how do we?
So what happens is, when it does this condition, it says, is 4 equal to 4? And when you ask is 4 equal to 4, what do you get? True. And what's true? Yeah, 1. So 1 is like saying true. It's like saying if true is equal to true.
So there's an implied if whatever is in the brackets, and the if equals true is implied.
Yeah. Because what will actually happen is this expression will be evaluated. Is 4 equal to 4? The result of that operation will be 1, which is true. Yep. Yeah, I agree. These ones seem weird. But this is saying, is true true? Yes. Yeah. Is false? No. Yeah. Yeah?
I thought when we write return 0, it means return true, right? But I don't know, is it correlated? What does it mean? Like
At the end, when we return 0 at the end of our program, we're saying 0 errors.
Oh, okay.
0 errors.
Just wondering about that.
Yep.
Since 1 is true and 0 is false, if I instead wrote a mathematical expression like 3 minus 2, which would result in 1, would that be true or?
Yeah, that could be true. And actually, anything that's not 0 is accepted as true. So if I wrote if, that'd be treated as true. But generally, if we can, we usually use 1 and 0 to denote true and false, but C will accept anything that's not 0 as a true. Yep.
So I was asking for if statement specifically, that if, say, instead of writing the brackets, we just indented it properly, is that fine?
So in C, the question is, do we have to have these brackets and indent it? First of all, if you've done Python, you have to have indentation to do stuff. In C, you don't have to have indentation. It'll still work. It's just that your tutor won't want to read it. But, yeah, if we've got one line, we don't need those curly brackets. I think in this course we prefer them because if you've got more than one line, you need those curly brackets. And usually you will have more than one line. Okay, so these are, oh yeah, sorry.
Suppose in if expression, we use a mathematical expression, equals to 0. So like we're checking if the answer of the mathematical expression is 0 or not. So what is gonna it do? Like,
well, if we have something like, we'll go to a break in a minute. If I have something like if x is equal to 0, it's just going to check, is x equal to 0? If it is, that will be true and it'll execute. If it's not, that will be false and it'll execute. All right? Yep.
So I have two questions. First, can you write a multiplying expression there? Like for example, is x multiplied by a equal to 0?
Yeah, you can have more complicated expressions in there.
Second, can we do ors and
The question was, can we have like arithmetic expressions in there? Is x times 2 less than 100? Yes. And then the other question was, can we use logical operators? That's what we're going to look at after the break. So yes, but if you don't know what a logical operator is, doesn't matter, we're learning it after the break. Yeah, one more question, then we'll have a bit of a break.
So what if one doesn't hold any inherent value, like it's not equal to true as it is, and that like 10 could also be true? What is the if actually checking for?
If is just checking for true or false. So you can put weird stuff in there and get C to go, okay, you're talking about true. But generally we want to put some kind of meaningful condition in there.
So the 1 doesn't actually mean true, it's just the fact that it's not 0 that one's different.
Yeah, anything that's not 0 is true. But if you've got, like those relational operators will give you 1 for true. So 1 is a common value for true. All right, let's have a break and we're going to come back and we're going to do more if statements, do more complicated situations. Let's just come back at about, let's have a 10-minute break, come back at 10 past. Yep. Okay, so welcome back from the break. Is this on, or am I just getting used to my loud voice? Can you hear it at the back? Yeah? Okay. Tell me if you can't hear or see anything. Also, I'm not a fast typer. Some of you probably thinking, yeah, we didn't think you were. But if you do, like if you start typing something and press tab, it tries to complete it for you. Okay. I just thought I'd just share that. All right, so we looked at if statements. So with an if statement, we could choose to execute a block of code or just do nothing. Here we can choose between two things. We can say if the condition is true, I want you to do one thing, else I want you to do another thing. And that's really common that we want to do something like this. So the code, if the condition is true, will run the code that's inside this block and skip past the else part to the end and then continue executing. If the condition is not true, it'll skip past this code and go straight into the else part. All right? Okay. So here's an example. I don't know, I don't really know the degrees that make people cold or hot or whatever, so you may not agree with me, but I've got cold 10 degrees. If temperature is less than or equal to cold, it's printing I'm cold, else it's printing I'm not cold. So this is just a very simple example of what you can do, and obviously I've used a hash define. All right, any questions about that? And actually you can make things even more complicated, well, not more complicated. I'll just wait till people have come in and settled a bit. Sometimes you might, so here we've got two different things that could happen, printing I'm cold or I'm not cold. Maybe you want more things that can happen. There are more different things. Maybe I'm cold, I'm hot, I'm just right kind of thing. So you can actually chain a whole bunch of conditions. Yeah, I can have if, else if, I can have even more else ifs. At some point, if you've got like hundreds of else ifs, what are you doing? But you can have a few else ifs and maybe an else as well. So this gets you to choose between different things that you might want to execute. So it does it in order. So it's first going to look at condition 1. And if condition 1 is true, it'll do that. It won't do the other else ifs. It's not going to even look at those. It'll do that, jump to the end. So it's only going to execute one of these sections. Okay, so here I've adjusted it. Again, you might not agree with my hot and cold. I don't even know if I agree with it. If temperature is less than or equal to 10, we're saying we're cold. If temperature was not less than or equal to 10, but it was less than 25, we're saying we're just right. So what would the temperatures be that would be getting the just right? What would the possible temperatures be? 23. Yeah, but all of them, like, yeah, so 11, 12, 13, 14, 15, up to 24. That'll be just right. Anything 25 and above, else, we're getting hot. I am hot. All right, does that make sense? Let's just run it. Now, when we run these types of things, or if we're testing them, we have to make sure we test all the different, hang on, let me find it. We have to make sure we test something from all the different categories and borderline things. Like if you'd written this code, you'd want to test the temperature, say 10, 9, 11, like those borderline cases, 24, 25, 26, then maybe weird stuff, I don't know. So have I already got this compiled? I don't think so. So I'm entering 10, and it should tell us that I'm cold. I'm going to enter the temperature. 25 should say I'm hot. And 11 should say just right. Now notice all of them say, have a nice day, because that's outside of the if block, the if else sort of block. So it's going to do one of the things inside here, whichever this condition, if this is true. If that's not true, it'll look for this condition. If none of them are true, it'll do this. Regardless, then they'll all continue on executing, you know, the rest of the program. Yep.
So if the first one, the if is true, it's not going to look at anyone else.
That's right. If
If there are multiple else if statements, and for example, 2 of them are true, is it going to print both of them or just the first one?
so, if there are multiple else if statements, and actually more than one might be true in a situation, it's going to do the first one. It does them in order, and if one's true, it's not going to look at the rest. Yep. Okay, so that's else if. All right. Yep. Yeah, it doesn't have to have an else at the end. So I could just, instead of printing out hot, I could not even have an else, and then it's just going to say, you know, if I type in 25, it's just going to say have a nice day. It's not going to do anything. So yeah, there might be some situations where you don't want it to do anything unless it's those specific conditions. Or yeah, you might want the else to just do it for everything else. Yeah, it just depends what you want. There's lots of options. Okay, let's just do an example. So we're just checking whether an integer is odd or even. And we're going to use an if statement. So if it's even, we're just going to print out even. If it's odd, we're going to print out odd. I guess the hardest thing about this is how do we work out if a number is even or odd in C? Wow, I can hear everybody saying modulus, which is great. So yeah, if I use modulus, I can find out if something's divisible. If something's divisible by 2, it's even. So if I do mod something and I get 0, there's no remainder, we're divisible. Divisible by 2, I'm even. So let's code this up. And this is a common thing, you'll use mod a lot in computing to do stuff like this. Okay, I've just to make it quicker, I've already printed out please enter an integer, and I've got my variable for the number, and I've got the scanf. So I'm reading in the number. So now we just have to do the if part. So yeah, I'm going to type if. Now what's my condition going to be to see if something's even? Yep, so if number mod 2 equals 0. Yep, that is if we get 0 when we divide by 2, like as a remainder, if the remainder is 0, when we divide by 2, it's even. So now we print even. Now, what do we want next? Yeah, we can do an else. If it's not even, it's odd. Now, I don't know if there are maths people here saying 0 is not even, or I don't know if it is or not, is it? It is. Awesome. That's it then. If even, else odd. Okay, let's compile it. And let's try and run it. So yeah, if we put 0 in, we get even, which apparently is correct. 10, even, 99, odd, What else should we test? Sorry? A negative number. Oh, I've got to type it in at the right time though. It's getting too excited. Odd. So it's working for our negative numbers, which is good. Oh, I can't type it in at the right time. That's good. Okay. All right. The next thing we're going to do, I've forgotten, the guessing game. And we're going to build on this guessing game, but for now, we're just letting the user have one guess. I can't find it. Let me just... Okay, so our guessing game basically is we've got a secret number. Now, in our guessing game, it's hard-coded to 42. Often in games, we might use like a random number generator so it's different every time. But for us, we haven't learned how to do that yet. Plus, we want to easily be able to test it and get the same thing every time to test it. All right, so our secret number is 42, and I've got it as a hash define. The user is just trying to enter an integer and get the right value. Now, if they get it correct, we're going to print out correct, funnily enough. If they pick something that's too low, we're going to say higher, like no, go higher kind of thing. If it's too high, we're going to say no, go lower, whatever. So what's the first thing we could check for?
The number.
Check what?
If the input is valid or not. Like they could enter characters or
Oh,
we can return one.
okay. So the suggestion we have is a really good suggestion, and we'll come back and do it later. Check whether they've actually even entered an integer. But haven't told us how to do that yet. So that, I'll tell you after we've done this, we'll be looking at that. But that's yes. Let's assume they have entered an integer. What's the first thing we might want to check for? Yeah, if it's equal to 42. So if our guess is equal to, now, do I want to type 42 here, or what do I want to do? Yeah, if we've got these constants, yeah, use them. All right, so if our guess is correct, I'm going to print out, funnily enough, correct. What's the next thing we might check? Yeah, so if it's higher than the secret number, it would work. If we put 42, the code would work and it would run. But if it was an assignment, your tutor would then say, oh, we call it magic numbers if you've got like a 42, because if I look at 42, what are you doing? What's the 42 mean, you know? Just a word of warning about hash defines though. We don't want you to go overboard and start doing stuff like this. Now, why is this unnecessary? Because the meaning I get from the word one is the same meaning I get from the number one, or like, you know, that doesn't give me any more kind of meaning if you just do that. I read 5, I look at that digit and see 5, right? But with this hash define, it's giving meaning to this 42. It's like, oh, well, that's what the answer is. That secret number. All right. So now what was I saying that we print out in this case? So if the guess is too high, so imagine they guess 45, what am I saying? Yeah, I should say too high really, that was better. Who said that? Someone suggested too high, that would be better. I've written though lower, yeah, as in go lower, just to keep everyone on their toes. Now, what do we do next? Yeah, there's no other situation at this point. Unless, yeah, they didn't actually enter a number, but we'll learn how to deal with that later. Okay, let's check it. please enter an integer. Correct. Please enter an integer. 50. It's going to say go lower. 5 higher. Okay? All right. Let's move on. Oh, nested if statements. Yeah, we're running behind. We've already had our quick break. I might come back to that nested one in a minute. All right, here's some logical operators. I'm just going to shut the door. They're moving furniture or they're doing something up there. Okay. So sometimes we want to ask more kind of complicated questions. We might want to ask sort of two things at the same time for our condition, like is x greater than y and is y less than z? So we can use these logical operators and, or, and not. Who've heard of these before from like other subjects? So sometimes people do them in other courses, like especially in engineering and stuff, you probably see these, I think. So in C, for and, we put the 2 ampersands. For or, we've got these 2 vertical bar things. It's usually above the enter key if you press shift. Exclamation mark means not. So true. Oh, and if I've got 2 conditions and I'm anding them together, both conditions have to be true for my whole expression to be true. So in this situation, we'd need x would have to be greater than y, and also x would have to be less than z for this to be true. All right? With or, only one thing has to be true. So x has to be equal to max, or y can be equal to max. They don't both have to satisfy their conditions, right? Only one of them does. Now, with not is just going to take whatever, you can put not in front of an expression and it basically like reverses it. So if you've got true, not true becomes false. If you've got false, not false becomes true. Okay? All right. Now, some people can understand that from that sort of just, you know, that sort of level of explanation. Some people like to have really specific things like truth tables, which really lays out every permutation and combination of possibilities that you could have. Some people look at these and don't like them. So whichever way works for you is fine. But what truth tables show you is, imagine I've got 2 conditions and I'm going to AND them together. The possibilities are that both conditions are false. Oops. The possibilities are that both conditions are false. If I AND them together, I'm going to get false. Okay? The other possibility is I've got one condition that's false and one condition that's true. When I AND them together, I get false. True and false, I get false. True and true, I get true. So these truth tables just go through all the possibilities. And for AND, both conditions need to be true. All right? For OR, you know, we only need one of our conditions to be true for I can't even speak, our whole expression to be true. It's only if they're both false that we get false. With our nots, if we've got a condition that's false, we get true. If we've got a condition that's true, we get false. So that just summarizes all the possibilities. Okay, now, if you're used to doing maths, you might, in maths, see things like this. Naught is less than x, which is less than 10. And you're used to that meaning x is between 0 and 10. That's not what it means in computing. So if you type this in C, it looks reasonable. it doesn't actually do that. It's not going to check if it's between 0 and 10, but it might do something, so you might think it works. It'll give you some kind of answer. How we would actually do that is like this. We'd say x is greater than 0 and x is less than 10. This is how you would do it. Now, sometimes beginners get their ands and ors a bit mixed up. So instead of doing that, they might also do something like this, right? Now, can everyone see that this is always true? So no matter what number you pick, so if I pick 100, well, 100's greater than 0. And only one of the conditions needs to be true. So it doesn't matter that it's not less than 10. And it'll go, yep, 100's, that's fine. If I say minus 50, this one will fail. But yeah, that's less than 10. So actually, this is just always going to be true for everything. Okay? So sometimes these things can hurt our brain a bit. But people will accidentally do that. I really think they will. This one here is always false. A number can't both be less than 0 and also greater than 10. So that's going to be false. So sometimes you can get things a little bit wrong and end up confused. That's part of learning all of this stuff. But there are my warnings. Okay, what do we think this does? There's 3 conditions. The first one is asking, is the character A greater than or equal to basically the character G, right? This is what our variable is. Okay, is the character G greater than or equal to the character A? Yes. Yeah, because remember they're stored in order. G comes after A in the alphabet, so that's true. Is the character G less than or equal to the character M? Yeah. So this is basically asking, is G somewhere between and including A and M in the alphabet? So we can do conditions on our characters, which is handy. What's this one asking? Is x less than 0 if we know that x is 4? No. Is x greater than 10 if we know x is 4? No. So if we OR this together, we're just going to get false. What about this next condition? Yeah, I can hear people saying true. So we already know that this inside part is false because that was exactly the same as the last condition. If you put a not around it, we're going to get true. Okay, so that just does the opposite. All right. And typically nots can be a little bit confusing for a while as well, but you do get used to all this stuff with some practice. All right. All right. One last thing before we do a little bit of coding. Again, if I've got this situation, is this going to be true or false? And can I possibly work it out if I don't know the value of y? Or can I not know? Yeah, how come? Yeah, it's ORing. We're ORing. So if I know that this is true, it doesn't even matter what this is. Yeah. And C's smart enough to know that too. So C won't bother looking at the rest if it already knows, oh, well, the first one's true and I'm ORing them together. And we call this short circuit evaluation. Down here, what about this one? Yeah, I already know it's false because x is not equal to 3. I know it's false straight away. C is not even going to bother worrying about y. Are there any questions? Does that make sense? Again, this is just to find a point of C's conditions. All right. Let me get onto this. So the next program we're going to write is we're just going to write a program where users can enter a character and we can print out whether it's uppercase, lowercase, or not a letter at all. All right? And when we're checking it, again, we need to think about all the different cases we might want to check. So, all right, so the first thing is I need to declare a variable to read the character into. And let's just call it character. And I might just print it out, please enter a character. And I'm going to use just the normal %C because if the user enters a space or a new line, that's fine. I want to know what they entered. I don't want to skip it. So once I've read in the character, what am I going to do? How can I check if something is, yeah?
Check if the variable that the character stored is between the ASCII values of the uppercase A and uppercase C.
Yeah, we can check, is it between uppercase A and uppercase Z, and then we know it's an uppercase letter. So to do that, I would type if character is, what do I type? Greater. Now, we could put the ASCII codes in, but we don't want to. We like to just put the letters in. So I want something like that. Do I want greater than or equal? Yeah, because I want to include capital A. Now, am I going to put an and or here? And the character has to be greater than A and it has to be less than Z. Yep. Oops. Okay. There we go. And then we know it is an uppercase character. I'm just going to type that. Now what I'm going to put? Else if. That's right. And I basically want to do the same thing, but for lowercase. Okay, and then I'm going to print out lower. Lower. What else? I didn't mean to say that. Yeah, else. Everything else is just not a letter. Yeah. Now we could do more cases. We could check for like white space versus, I don't know, other categories of things, but this is all we want to do now. We've got if it's an uppercase character, else if it's a lowercase character, else. All right. Let's compile it. Character cases. Okay. So A, yay, it's uppercase. Lower, etc. Let's just type in a space, not a letter. So you'd want to test it a little bit more than I just did, but we're in a lecture and the time's ticking. Yep.
If I type in a number that corresponds to a letter, will it actually register as a letter?
So if I typed in, say, if I typed in 97, that would correspond to two characters being typed in. The character 9 and then the character 7. So if I'm doing %C and I type in 9, it's just 97, it'll just read that 9 as one character, the character 9. So let's just try it. Like even if I type in 97, it's going to read in one character. So let's just print out what character it reads in. And actually, let's even print out its ASCII code. So normally we don't need to know the ASCII codes, but just if we're trying to understand stuff, it can be helpful to print them out. So, you know, if I type in a capital A, I think so many people have already memorized this. It's going to say A, but the ASCII code is 65. Now, if I type in something like 97, it's reading in one character. It's reading in one thing I've typed in, and it's it's reading in the character 9. What's it printed out? What number is it printed out? 57, because all of our digits are characters that we can type in. So one digit is one character, and it's stored in the ASCII table as well. So there's a difference between if I say char, I don't know, equals the character 9 and the number 9. So if I want to start doing maths, like real maths with the number 9, and I'm doing that with the character 9, what is going to be the issue? Well, what number is the character 9? Yeah. So if I do C times 10 or something, I'm doing 57 times 10. Whereas if I do X times 10, I'm doing 9 times, you know. So be careful, the character 9 is different to the integer 9. And you'll be playing around with that and getting used to this whole idea of characters and numbers. I think in this week's lab, actually, you'll be doing a lot of stuff, I think, with chars in this week's lab. Okay, and that's one thing that definitely confuses people to start with. All right. Breaking things. How much time do we have? Okay, yeah, let's do this. So, I've got a question, yeah? Oh, sorry. Dec in the ASCII, and I didn't mean to show the full ASCII table because it's confusing. Shh. Dec means decimal. So decimal means base 10, which is the number system we all know and love. Hexadecimal means base 12. It's a different number system. You know how we've got binary, decimal, hexadecimal. So don't worry about hexadecimal. We know decimal. So just ignore that column.
Is it base 16?
Yeah, it's base 16. Base 16. Sorry, I don't know what I just said. I said 12. Sorry, base 16. Base 16. All right. So we had a suggestion before about trying to find out whether the user actually even typed in an integer in our guessing game. What if they just typed in hello or I don't know what? So it's really good practice to think about, I mean, you need to work out that your code's right, okay? You need to try and debug your code. But if you've got a user typing stuff in, you can't control what they might type in. So it's really good to make sure you've got errors to check what they're doing. And these errors in this slide, they're example of very bad error messages. We don't want ones like those. But how can we actually check from Scanf whether the users typed in what we wanted? So Scanf actually gives us back a value to tell us how many things it successfully read in. So if I'm asking Scanf %d, if I'm asking Scanf to read in 2 integers, I'm saying %d and %d. If the user types in integers and it can read 2 integers in, it will return 2. Return just means give me back a value, and then I can store that in a variable, or I could print it out, or I can do something with that value too. So Scanf will both read those things in and say, hey, yeah, I read in 2 things. Now, let me run it actually. Oops. Okay. Here it is. Now, let's just try this. So the ideal case is that the user is going to type in 2 numbers. And scanf is going to tell us, and we're storing that in this particular variable, yep, we got 2 inputs read in. And now I've printed it out. I'll just move this a little bit. I've printed it out that we did get 2 inputs. And I can then check that in an if statement. If I got 2 integers, that was good. If I did not get 2 integers, in this case, that's bad. What happens if I type in something like 3, then hello? Scanf is going to tell me it successfully read in how many things? So how many correct inputs do I have? 1. So it was supposed to read in 2 integers. I gave it 1 and a word. It'll say, oh, the user only typed in 1 integer is basically what it's telling me. Yeah? If I typed in just hello, all sorts of rubbish, scanf is going to tell me I successfully read in how many integers? 0. So it's going to give me back a number that I can store, and then here I've printed it out. Scanf was able to read in 0 inputs. And I can check for it. I didn't get 2 valid inputs, therefore I'm going to print out this error message. Maybe we could print out a better error message saying enter integers, or you did not enter an integer. But this is how scanf can help us work out whether the user typed in the right thing or not. Does anyone have any questions? Yeah?
So the line 11 basically counts the number of inputs.
So on line 11,
So
yeah.
what's the function of that line 11? What is it doing?
So on line 11, because this is really important and it's a bit tricky. So usually we just run scanf like this, right? So it's like if I go and ask you to get, I don't know, 2 numbers from somewhere, I don't know why I'd ask you to do that, and you just go off and do it, and then I don't even, you give me, I'm not even paying attention. But I could ask you to do that, and you could come back and say, actually, I only got 1 number. That's what scanf can do. So the way we get that value from scanf, we say it returns it. It gives it back as a value we can use in our program. So it's going to try and put the values that it reads into our x and y variables, but it's also going to say, hey, yep, I read in 2 values, or hey, I only read in 1 value, hey, I read in 0 values, whatever. And it gives it back and we can store it into a variable. We can call this anything, right? It's just going to be some value that it gives back to us that we can store in a variable or use in our program, okay? And then I can look at that variable. If that variable equals 0, if that variable equals 1, I didn't get the valid input that I needed because I needed 2 integers in this situation. If I got 2, then I know, oh, okay, that was valid, okay? So we call this a return value. A function can do something like try and read in the x and y. It can also return a value that we can then assign to a variable or examine in some way or use in some way. Okay. So if I wanted to go back to our guessing game, and I wanted to check if the user entered valid input, what would scanf return if this all worked properly? If the user typed in valid input, what would scanf return? 1. Yeah, who said 1? Yeah, because we're only asking the user to type in 1 integer. So if scanf says, yep, they typed in 1 integer, we would think, oh, good. We only wanted 1 integer. That's fine. They were able to read in 1 integer. So it depends on how many %Ds or % whatever you got that determines you know, whether you got enough input that you wanted. So we could say here, and we can call this anything we like. I'm going to get that value from Scanf. It's going to tell me how many things it read improperly. I'm putting it in this variable. And I can say, well, if valid is not equal to 1, something was wrong. Now, in this case, I might then want to finish the whole program. So this is the kind of case where we might say, let's return some error code. So here, our 1 is meaning bad error. Yes, errors. Here, our 1 is, did they type in one integer or not? Yep. So we can do something like this. The other option is we could have added it to our if, else chain. We could have had if was scanf input valid, else if. But I'll do it like this. Oops, wrong one. So let's enter an integer. Actually, let's not enter an integer. Let's enter rubbish. Now, scanf is going to say 0. I read in 0 integers. And my program is going to be able to detect that and print out you did not enter an integer and end. Okay? Are there any questions about this? All right. Well, we're running out of time. We've done that. Okay. We're not going to start while loops now, but I wasn't sure that we would. We'll start while loops on Thursday. All right. And we didn't get time for our Kahoot. That's all right. If you answered some questions today and you want a chocolate, come up now and get one. Other than that, see you on Thursday.